Hi, my name is Daniela, and I'm one of the first engineers in Tel Aviv to work on Google Cloud. Today, I want to talk about what my team, the cloud networking team, is working on. But first, a bit of history. Google Cloud development in Tel Aviv began in 2013, when we started working on Cloud VPN for GCP. By 2018, there were over 50 engineers working on cloud networking in Tel Aviv. Between 2018 and today, Google acquired three startups that joined the cloud organization: Velostrata, Aluma, and Elastify. And we saw a lot of growth across all the teams. Today, there are over 250 software engineers working on cloud, in addition to a growing business unit, which includes marketing, sales, and customer support. Overall, Google Cloud is the biggest organization at Google, as well as the fastest growing one. Now, back to cloud networking. What do we do? 10 years ago, when you imagined a computer network, it looked like this. Lots of hardware, and every function is done by a box. Today, not every organization has to own all this equipment and carry the burden of operating it. In the world of cloud computing, anyone can spin up machines that are connected by a network and have all the functionality they need without owning a single piece of hardware. In order to make this happen, my team built an impressive software stack, which enables everything from basic connectivity to firewalls, NAT, load balancing, and much more. One of the most challenging challenges in building the stack is scaling it to support networks with hundreds of thousands of endpoints across the globe. Today, I will show you three of the principles which we use to build a scalable network. The first principle is avoid bottlenecks by avoiding middle boxes. We don't want our performance and cost to deteriorate with the number of features we build. In order to meet this requirement, most of our functionality happens on the host, where the VMs are running. Otherwise, middle boxes become bottlenecks as the network grows. However, this approach comes with its own challenges. Every host can run VMs from many different projects, and we need to program it with all the information to handle traffic from all these projects. As the networks grow, this creates two issues: long programming time and huge configurations that need to be stored on each host. This brings us to the second principle: leveraging the long tail. We analyzed the traffic on cloud networks and found out that most of the traffic is concentrated in a small percentage of the possible connection. The majority of possible connections either have very little traffic or no traffic at all. Using this information, we added a middle box after all, but now for a specific feature. This middle box, called hoverboard, is programmed with all the information for all the possible connections, but it only needs to handle a very small amount of traffic, so it does not create a bottleneck. When a machine first sees a connection, it sends it to hoverboard to be handled. Once hoverboard sees that a connection surpasses a certain amount of traffic, it gets offloaded and programmed directly on the host. The third principle is flexibility. In order to maximize our use of resources and provide our customers with the best performance and reliability, we need to be able to move virtual machines across physical hosts without the customer being affected. This way, we can optimally bin pack virtual machines on the hosts. Live migration enables us to migrate customers' virtual machines without any downtime. Leverage our software-defined network to handle the migration, routing traffic from the old machine to the new machine until programming has been propagated everywhere. To summarize, these three principles and more enable us to build a fast, reliable, and scalable network for all of our cloud customers. Want to hear more? Go to cloud.google.com/networking. And now, Yoav will tell you about another exciting area we're working on here in Tel Aviv. On to you, Yoav.